Our project is called Autonomous Tetris Player. First, I'm going to talk about our initiative. There is a lot of videos on the internet showing computer playing video games by itself. Using reinforcement learning, the model can be trained to achieve scores that are even better than some people. We wanted to train the computer to play a video games that is entertaining and not too easy. That's why we choose Tetris. We implemented Q-learning and reinforcement learning. So what is Q-learning? Q is actually a table that contains scores corresponding to actions that took in different states. Therefore, after training, we can choose an action with the maximum score in every state. However, unlike a lookup table, a neural network uses weights to represent the parameters in the table. So our Q function actually looks like this, where theta is a vector of parameters. And instead of iteratively updating values in a table, we will iteratively update the theta parameters of our neural network so that it can learn to provide us with a better estimation of state action values. In our scenario, states implicates simplified screenshot, and action includes moving left or right, rotation, and do nothing. This is the loss function used in our implementation. Q takes in states and actions as inputs. The score takes into account of not only the rewards that will be gained due to a certain action, but also the future rewards that might gain because you choose the action at this moment. We choose the decay rate as 0.99 because we wanted the game to be played as long as possible. In most implementations, people use random moves to train the model. However, in Tetris, if we use random actions, it would be really hard to complete a line in random actions, and therefore would take a huge amount of time in training, which is not efficient. Instead of using random only, we introduce best route strategy. The concept is trying to maximize the score in every move we made. So we set a formula to calculate the score for each action. The formula is completely built on human knowledge. The reward includes the completion of a rule. The penalty includes maximum heights, number of halls in the moment, the fluctuation of heights between columns, and whether the pieces has moved or not. And we pick the action that gives the best score. We did not use this strategy only by itself because we cannot use this simple strategy to reach an optimal score. For example, we did not take the next piece into account, or sometimes it would have some deadlock situation if we have more than two values. We need random action to compensate it. We trained our model for 1 week, and this is our final result. As you can see, there's still some bad decisions. If we take some more time to train, maybe it'll give a better result. Thank you for listening.